Hi guys, Mr. Johnny here. In this video, that's the first video you see in this shed, well, after that update thingy. I'm gonna take a look at the CFL, but not a boring usual one. This! Yeah! This goddamn thing, which you can see is humongous. $65 watts, 4000 kelvins, E40 base. I mean, like, take a look at this bastard right here. That part is ceramic right there. It's a humongous beast, which is huge. Okay. I think it opens the same way any usual CFL opens. You might think that you can pry it like that, but that's not the case. I can see a seam right here, and that's where I need to pry. So let me do that off camera to save you the boring stuff. Well, it wasn't that easy. It took 3 items: knife, blade, and a screwdriver. But I get it done. Let's take some dead insects right there. Nice. Oh, and in there we see also this. It's a resistor, or what is left of it. Oh, sorry, it's not a resistor, it was an inductor. Let's give you a look. Atrocious lighting. I'll have to find something else. But that's the thing we're interested in. Oh, right there. I guess it is in series with a bulb tube. Huh, interesting. Anyhow, what do we have here? 22 microfarads worth. As for the transistors, we have 13007s. If you can see that right there. Quite a nice core. It's pretty big. It's about an inch across like that. So first thing first. Oh crap. I see a fusible resistor on the inside, and as you can see, it did fuse. It went all fusible there. That's not very good. That means the transistors are blown. Most likely that is. Okay, it is still worth repairing if the tube is alright. And the tube will be alright if the filaments, which are at the ends right here, here, that's our favorite word over here. Let's beep them out, see if they're okay or not. Filaments should be beeping across these 2 pins and these 2 pins. These are wire wrapping pins. It's a method of connecting the tube to the circuit board. It's just a pin soldered into the PCB, and the wire directly coming out of the tube gets wrapped around it, and it makes a good enough contact for the current that flows through this device. Let's measure it here. Okay, that's alright. Cool. Now, to be extra sure, you need to break one connection from the tube of each filament and beep it out that way, because there might be something shorted or damaged, or even in normal operation something may interfere with the measurement. But alright, I'll have to take it out anyway. So I'm gonna grab hold of the end and unwrap it. Like, oi, oi, oi. Like that. And as for the other one, 1 turn, 2, 3, 4, 5 turns. That's nice. Again. Well, I think that's the end of the video, because yeah, the wire pulled right out. So the tube was not dead, but now it is. Nice job, Johnny. Nice job. That's a goddamn actually too bad, because you can see from the ends right here, you see no signs of blackening here from the sputtering action of the filaments, which means the tube has not been stressed in its life before I got to it. As you can see, one wire goes out of the tube and like that, and the other goes through the hole in the PCB. And you have to be extra careful to make sure you don't pull the wire out. Yeah, you can see some burn marks where the transistors are. You can see here and here. Cool. Some burnt out resistors, choke. Those are emitter resistors. There are emitters, so the transistor pinout is like this: base, collector, emitter, from left to right if you're facing the marking. So the emitter is third pin here, and it goes to these burnt resistors, and from those resistors it goes to the collector of the other one. It's a typical half bridge. That's the end. Broke the tube. It could have been repaired, but not now, not anymore. Well, I can actually make a driver that will treat this as a cold cathode fluorescent lamp, and it will be fine without two connections to the filament. But that will stress it a little bit. Although this thing, that will stress it on the startup quite badly. But this thing is, as you can see from the gargantuous base, it's a E40 again, 40 millimeters this way. It was not an indoor lamp to start with, it was outside, and it was located outside as kind of a surveillance light, as a security light that gets turned on in the evening and shines till the morning comes, and yeah. So I can actually make a little boost circuit that will power it, but I'm not sure about the power dissipation of it. This goddamn half bridge got bloody hot in its life, as you can see from the discoloration of the circuit board right here. You can see that it's light brown here and almost like a charcoal right here. Same stuff here. This transistor got bloody hot. What caused the problem, you might ask? I'm gonna say an overheating situation. Could be some dry solder joints, but I don't see such a solder joint that would cause this kind of crap. And yeah, it's alright. Well, it was alright, now it's not. Now it's a piece of garbage. Garbage. Anyway, thanks for watching. See ya.